doing. I say and other innovations because prior to doing precast pavement, we were doing some other innovative things. So I'm going to share some of those ideas. And hopefully I'm not too repetitive. There are many things that many of the other speakers have already said that I could say, vouch for those things. I could say them myself. So I'm going to try not to be too repetitive. I provide this quote because to me it exemplifies what we've been doing. If you want to make change happen in your work environment or in your highway environment, they don't just happen because you want them to happen. You have to really work and advocate and struggle and sometimes argue or fight with whoever is in the decision-making area to try to get things done. They don't just happen by accident. Somebody has to be there pushing for them to be done. So that's why I kept this quote in there. Now, what we've been doing is coming up with different pavement replacement tools because, as Utah mentioned, we're trying to preserve our concrete pavements with concrete pavement technology. For many years, the asphalt industry was looking at all these nice concrete pavements and they were going to overlay all of them. And then guess who came along and started trying to preserve pavements with these different strategies instead? So one of the first things we did back in '95 was implement some sharp technology that was the Strategic Highway Research Program to use non-impact methods of removing concrete pavement. These methods are extremely fast. I went out there one night to videotape it with the guy that I call my cameraman. He's the department's cameraman, but I like to call him my cameraman. It's Hollywood after all. And they told us to show up at 11:45 because they're going to start working at 11. We showed up at 11:45 and it's like there's a big hole in the ground. They had already finished removing the panels, about 20 panels in 15 minutes. And so we had to go back out there another night to see them do that, to get the filming done on that. Then we've been working with trying to get fast-setting pavements, and so another tool in that aspect is fast-setting bases. We want to open up the base quickly so we can get the new pavement put on it quickly, including overlays with asphalt concrete and concrete pavement, and now precast pavement. We've been working with rapid strength concrete. Some of our earlier work back in the mid to late 90s seems to be much more successful than some of the more recent rapid strength concrete pavements. I have a slide I'm going to share with you in a little bit that kind of illustrates why we're really interested in something that can take more loading than just a plain unreinforced concrete, even if it is a fastening concrete. And then, of course, precast concrete pavement, which is one of the reasons we're here today. So there's other terminologies that you may have heard of. You know, obviously the bond breaker. You want the two layers, the pavement layer and the base layer, to act independently of each other. We do not want these bonded layers because you want the surface layer to behave the way it's going to behave and the base layer to be non-erodible so that if you get water in your joints or water under the pavement, it's not going to erode. You don't end up with what I like to call the Grand Canyon under your pavement because loss of support, as you've heard numerous times this morning, is one of the causes of pavement failure. So you want a non-erodible base under your pavement. In order to achieve full coverage under your pavement, we do under slab grouting. I am in favor of cementitious grouts, and you can talk to me later if you want to hear more about my opinions on other types of grouts. There's spall repairs and crack sealing for some of these items because things go bump in the night. Contractor isn't always very gentle with products that he's delivering to the job site. And then there's isolation joints, which separates the new pavements from the existing pavements, and expansion joints in case you're placing fairly rigid pavements in areas where you expect them to expand, and you don't want to have blow-ups on, when your weather starts warming up, because most of this work we're doing is at night. We have a lot of traffic control concerns, and most of our traffic issues make us or force us to do construction in the middle of the night from 11 at night and reopen at 5 in the morning, and that's very typical. The 6-hour work window, and it was unheard of in the early 90s to be able to do any kind of construction, remove pavement, place concrete, expect it to be strong enough for people to drive on, and then us open it to traffic at 5 a.m. You couldn't do that kind of work back in the early 90s. And so that's one of the things that prompted me to get involved with all these different strategies that I've been getting involved with. Since we had the Northridge earthquake, and you may have heard of the Northridge earthquake back in '94, we started doing work on extended weekend closures. And one of the big jobs that I worked on the I-10 replacing pavement, was one of the first 55-hour closure weekends in California. And so that's getting more and more common. There's a job you may hear about, the 710 freeway, which is replacing 36 lane miles of concrete pavement with precast. It's not as big as the job in Indonesia. It's only 36 lane miles, but it's a big one. It's going to have 37 extended weekend lane closures. Movable barrier, temporary, I call it temporary barrier because they put it down for the job and then they remove it later. But during the job, it's semi-permanent. It's there. It takes about 4 hours to install and 4 hours to remove, so you obviously can't do that in a nightly closure. And then our typical work zone requires a 6-foot buffer, but the only protection for the worker is a bunch of orange cones, which, as you probably know, is no protection at all. This is what a lot of our older pavements look like. They're very beaten up. They're more than 40 years old. In a lot of cases, they're even 50 or 60 years old with increasing levels of traffic. And so these are the kinds of maintenance nightmares that our people in the field have to work with. And then, of course, if you're the driver, you don't want to drive on these things. They're awful to drive on. We even have places where water spouts up out of these joints right after it's rained, and that's kind of a strange experience too. So you can see this is a slide of the I-10 job that we did in Pomona back in the late 90s, and we used a movable barrier to push all the traffic over. And so that meant we had the entire 2 lanes and a shoulder that we could work in basically unimpeded and much more safely. So this is, I consider, an ideal traffic control situation. This is a typical, 6-foot buffer. Now that blue van that you see in the picture, that's not a parked car. That's a car driving by the work zone. While we were doing this Fort Miller type installation, this was done in December. And you might wonder, wow, look at all those highway workers out there. Well, most of them are observing. They're not actually, they are working in the sense that they're working on learning new things that they can share and do on other projects. So I don't know what the public thinks of this kind of thing, but it is useful to have a lot of people out there to see what's going on. Now, why do we need rapid repairs? People are impatient and they want to get on so they'll drive through fresh concrete, they'll do anything, even if it's a fast-setting concrete, they'll drive right through it. And so we need something that we can get people back on it as soon as possible. We saw the pavement in advance to remove it, and then there's different methods of non-impact, but 2 of the most common ones are just a regular bucket. Contractor doesn't need any specialty tools. Maybe he needs a skilled operator, but that's about it. And then the crab claw that is frequently used that you've probably seen in other slides. There's some non-impact lessons. We don't want to do too much sawing in advance. And if you have severe damage, definitely don't do a lot of sawing in advance because you'll have bits and pieces causing accidents. It is very rapid to remove. It's much faster to remove than it is to replace. The replacement really takes 3 times longer. And you can do this without damaging the existing base, which is usually in good condition. And then the contractor will say, but I want to rubbleize it in place. Well, that takes forever. Let him rubbleize it off-site. Let him rubbleize it somewhere else. He can recycle it somewhere else. So then this is a picture from the job that was done up in the Bay Area the last couple of years. You've probably met Tinu Mishra. This was on his job. He took our lean concrete base and ran with it. So this was really exciting that someone else was doing something that we were considering important. So you need lean concrete base rapid setting because you want to get on that base really fast. I mentioned the non-erodibility aspect of it. You have to have a nice smooth surface, and then we still put a bond breaker on top of it. And you have to avoid the high spots. Other people were talking about that earlier. And then you fill in any low spots with a grout that you pump in under the pavement. The Fort Miller people like to use they like to use a granular base, and I've been commenting to them for many years that they need cement in it. So they finally agreed to do that for us. And they delivered it on one of the projects we did with a ready mix, but there's no water in it. It's all dry, and then they grate it, and then they wet it once it's in place. So here they're wetting it, or I call it activating it. Wetting the bedding material doesn't sound so good. So activating the bedding material is a better. So we are using a 6-to-1 sand to cement ratio, which seems to work pretty well. You have to get it compacted and leveled out in the field. You have to wet it. We expect that will continue to gain strength so that when it does rain, it won't pump out, because we did have pumping. I'll share with you in a sec. And then they spray the bond breaker on the underside of the slab. I'll show you a slide of that too. And then we like to limit the thickness. And then if you're going to have anything thicker, you should use lean concrete base rapid setting or some other cementitious base. So this is a poured in place job. This was back from the late 90s. And this is one of the reasons why the poured in place isn't as successful. Most of our slabs are 8 or 9 inches thick. You can see that the amount of easels that they're handling is not very many. I put it in easels because I felt you'd probably understand that better than what we like to use as a traffic index. A 14-inch pavement on a treated base can get 240 million easels, but it requires strength gain prior to loading, and we don't always have the convenience of doing full lane replacements to get that 12 or 14 inches to get the better easels. So here's a couple of Precast Systems. You've heard about both of these, so I won't tell you more about them right now, but again, some of my bugaboos, and as you see, I already put this measure twice, cut once. That was a quote from Norm Abrams from This Old House, if you like watching public television. Precast thicknesses have an easel advantage, equivalent single axle load advantage. Some of the testing that we did, and I'll show you a slide of that, got over 150 million easels. That's a traffic index equivalent for us of about 16 and a half. Then it wasn't failing fast enough for the researchers at UC Berkeley, so they put another 90 million easels on it with an airplane load and finally crushed it, and then they called that a failure. But it wasn't a fair failure because they had to put an airplane load on it. So it got 240 million easels, the equivalent of a 14-inch pavement for only 8 inches of just plain reinforced precast. I thought that was pretty impressive, and that's one of the reasons my comfort level is very high with this system, whether it's a Fort Miller system or the PPCP, which is pre-stressed and post-tensioned. You do have to have it gain strength prior to transporting, and it requires some kind of care during handling. And then, obviously, as people have mentioned, it minimizes the delay to opening. So we use 2 kinds of bond breakers, plastic sheet laid on the ground, which is a nice bond breaker, or compromise that we've worked out with the Fort Miller people, because they don't like the plastic sheeting, is to spray the sides of the slabs. And so far that seems to have worked pretty well. We have to put in some isolation material around the edges of the slabs. And then dowel grouting or under slab grouting. Or if we're doing the top-down dowel bars, like a dowel bar retrofit, then we have to fill the slots with with backfill. We're currently advocating the use of a polyester concrete backfill instead of a cementitious backfill, because the polyester grout will not pop out and it won't delaminate, and there's a lot of other nice things about the polyester grout. And then joint sealing, obviously you want to keep debris out of those joints, because you do not want blow-ups, you do not want incompressible material in your joints. And so where we constructed them, well, a lot of them have been in District 7, and I guess you can bet why. But then fortunately we've had other innovative thinkers, some people in District 8 and District 4. And then finally we got our headquarters people on board, and now they've kind of picked up the ball and started running with it, and that'll be a very interesting thing to see. So here's some actual project photos. This picture is of the job that we constructed in 2004, using the same system except with a few little minor variations that was used in Texas and Georgetown in 2002. We wanted to have a 5% shoulder crossfall, a 2% roadway crossfall, and a shoulder crossfall of 5%. We knew that if we didn't do it on this job, people would tell us we couldn't do it because nobody ever did it before, so we did it. So you can see this slab has kind of an airplane wing shape, just so that we can achieve that crossfall. It's 10 inches thick because we're doing a strictly substitution during construction. We built 2 slabs of 125 feet approximately each, so about 250 feet as a substitution during construction, to show that we could do it. And we couldn't have done it without the help of Dave Merritt from TransTech, or from Sam Tyson, who's with the FHWA. One of the fun things that we found out is that once the money gets put in the account, nobody's willing to give it back, and they can't spend it on anything else. So guess what? They had to spend it on precast pavement. And so that was one of the nice features that happened during this project to get precast pavement built. This is them pulling it in from the trucks and bringing it into the job site. And you can see my cameraman there in the orange vest with his video camera right there, Steve Dvorkin. And this is what it looks like now. I took this picture in 2004, but it looks just as good now. And if you drive it, it's actually drives smoother than the pavement around it, which was also built in 2004. I keep talking about the heavy vehicle simulator. This was the piece of equipment that tested out those 8-inch panels and got 150 million easels. They even flooded it and pumped out the grout, and they still couldn't get the panels to fail. And they were in a rush to write their report, so they had to fail it for their report. So they put another, like I said, 90 million easels on it and finally crushed it to say that it failed. But we all know that it probably would have taken a lot more easels. Then some of the other work that's been done, I-15 in Ontario, California, CA, but the other CA, was done with a Fort Miller type system. And so after a while, all these pictures start looking the same. It's like, well, I saw that slide, that's from Utah. No, it's not Utah, it's Southern California, San Bernardino, California. It's like taking pictures of the ocean. After a while, all the pictures start looking the same. So here's what it looks like. This is at the 1510 interchange. So it's a big interchange in Southern California. And then these are the slabs that we did on the second PPCP job in Southern California. The plant was out in Paris, California, not the other Paris. And you can see all the slabs are stacked up, and that 2009 is not a misprint. They were cast in 2009, and they sat there for approximately 2.5 years until the contractor was ready to install them. He negotiated a contract change which allowed him to place them during the day, because otherwise we wouldn't have used precast on this job. We would have done all the work during the day with regular conventional materials. But because they'd already cast the panels to get the money up front early, they were sitting at the plant. They're not going to throw them away. So here they are. These are the panels in Silmar. More panels in Silmar. We had some interesting geometry that we tried to do to show that we could have different widths of lanes built in the same section. And this is now a nice, beautiful interchange. You have no idea where the precast pavement is when you drive over it. I've driven over it with guests that have come to my section, and we can't find them, but they're there. We know they're there. This was done up in the Bay Area. You've seen from Tinu Mishra, and you've seen some other people. Niraj talked quite a bit about the 680 job this morning, some of the unique features of that job. Again, after a while, they all start looking alike. Another one, this was in Montrose. This was just done in April, I believe. Montrose on the 210 freeway. Of course, everybody who was out there looking at this job had to, it's like, it's in the ground. Now we all have to stand on it and show that it's fuerte, it's working. You know, I call it kicking the tires. Everybody has to get out there and like jump on it and see what's going on. This night was also unique because it was drizzling. We had these intermittent rain showers, so that's why we're all dressed up in these really kind of warm rain jacket kind of attire outfits. And this was just done last month in Monrovia. I've driven on it several times, and it drives really nice. And for most of the jobs that we do, which would be a regular construction type job, we recommend grinding it afterwards so that you don't have to worry too much about warping and that kind of stuff, because you're going to grind everything. Everything's going to all be ground nicely. They're all going to have the same texture and profile. But these we didn't grind, and these are great. Maintenance doesn't do the grinding. And anyway, our maintenance people were really looking forward to doing this. And they would have done it about 2.5 years ago, except we had a giant fire in LA called the Station Fire, which delayed maintenance doing any other kind of work because they were cleaning up after the station fire. So now they're finally getting to do this kind of work, and they're kind of excited about it. So some of the benefits. You can get higher easels with thinner in-kind replacement. It reduces the need for full depth reconstruction. You can use a lot of the existing base if it's still in good condition. The cracking is reduced, and somebody mentioned fibers. We have started using fibers in some of these jobs. The steel fibers seem to be too harsh. They look like giant metal toothpicks. Some of the more structural synthetic fibers seem to be working pretty well. You can do in-kind profile. You don't have to adjust the profile. You improve your clearance under structures if you need to. Your removal costs are reduced, adjustments to all the other things that people forget about, guardrails, inlets, and all those things. Those add costs to the job that you don't have to do if you do precast. So if you do a full life cycle cost analysis, you might find that you're getting a good deal or a better deal than with other strategies. And of course, people have mentioned the increased quality. You get a controlled manufacturing environment. So future projects, those of you who are familiar with Los Angeles, or maybe not, you've at least heard of Sunset Boulevard, and you've at least heard of, Hollywood and Vine. You've heard of Santa Monica Boulevard. So this happens to be the intersection near Santa Monica Boulevard and Vine in Hollywood, California. And we're going to be doing some bus pad replacements. So maintenance is very interested in replacing some of their deteriorated bus pads with precast pavement. That way you can do the work overnight and don't have to prevent commuters from getting to work the next morning. So you can see that we have a lot of interesting things going on with precast pavement and other innovative features. And there's future work to be done. So, in summary, we're doing some interesting work under difficult conditions. And so now we have the technology, we can build it better, stronger, faster, which I thought was kind of interesting because they said that back in the 70s with the $6 million man. Well, now we can use that expression too. And I know we're going to wait for questions until the end. So anyway, I appreciate being able to share what we've done with you today.
Is there some questions? We can take a couple of questions.
No questions.
No questions?
Okay.
All right. Okay, thank you a lot for sharing your experience with us. It's so great to have so much examples of precast projects. So we'll go with the next speaker. It's Eric Brown from Lane Construction. Mr. Brown is a graduate from Clarkson University in civil engineering. He is a project manager for the Lane Construction Corporation, and he has spent the last 15 years working in the field of heavy highway and transportation construction. He worked recently on I-66 Highways for Life precast concrete panel projects, Fairfax, Virginia. He will present us a contractor's perspective. So Eric, the podium is yours.
Thank you. Good morning. I'll just repeat what Kirsten said. There's been a lot of slides that are redundant. We've seen a lot and a lot. I've actually seen some of my slides up here, including yesterday, today. So I'm going to try to offer up a different perspective. Right now, I'm sure you all know that any one of the speakers here could have spent about a couple hours talking about this operation. We're limited to 20 minutes. Being a contractor, I pulled some strings. I've got connections. I've got at least an hour and a half, right, Dennis? Is that right? No. So that not being the case, I'll try to keep this to the point and, again, offer up a little bit different perspective on what we're doing here. So I'll get right into it. Virginia DOT in the northern part of Virginia really has a high volume traffic area outside this, our nation's capital, Washington, D.C. This is a picture of the project site at an off-peak time. So this is where we were working, and this is, I would say, probably around 11 o'clock in the morning, about right now. So, this whole highway here that they're looking at doing, if I can skip ahead, looks like this, or actually looked like this. They've since done some other rehab to it, but this was back in 2008. The original concrete, built back in the 1960s, sits on 9 inches of concrete pavement, 6 inches of plain aggregate subbase, and 6 inches cement stabilized subgrade. So you can see the condition of the concrete they were looking at. Now, this traffic in this area, you're looking at about 184,000 vehicles per day, 5% which are trucks. I mean, these are commuters, and I'll tell you right now that working in this area, this traffic never stops. So this is the perfect application for something like this. In order to come through and do this job as a standard cast-in-place, slip-form concrete pavement, that type of work, you're looking at major traffic impacts. If you notice up here, They have a shoulder use from 5:30 a.m. to 11 in the eastbound, and then in the afternoons from 2 p.m. to 8 p.m. they actually take the outside shoulder as a travel lane, and you still have bumper-to-bumper traffic. So if you were to go and try to take 2 lanes of this in order to reconstruct it with conventional methods, you'd have a nightmare on your hands. You'd never have free-flowing traffic through this corridor, plus a lot of upset citizens. So again, perfect application for this type of construction, this precast pavement. Now, one thing I want to point out on this as well, and I've been taking notes, I've been listening to some of these different speakers, is that, we talked about cost comparison square yard to square yard, okay? What does it cost for square yard of precast pavement versus what does it cost for square yard of cast in place? Especially when it comes to conventional slip form methods or, large-scale projects. One thing to consider is if I were to go out here as a contractor, or even I'm sure as a designer or an owner, if you want to go out here and do a conventional cast in place, replace the whole highway, the first thing you're going to do is figure out what are you going to do with your traffic. You're talking major traffic control, costs, temporary barrier, crossovers, detours, all that is part of that cost of doing that conventional method. So to compare square yard to square yard cost on a specific item is something to think about. When you go out here to do a precast operation, we set up a lane closure at night, we replace the lane, we open up the traffic the next morning. So a lot of things to consider. It's not just comparing unit to unit, but project to project. So, when you guys as owners are looking into that, think about that. It's an important aspect of this. Moving forward, this is how we set up our traffic control on the project. If you look over on the right side, that's that travel lane was actually the shoulder lane. So at nights when we were going out here to work, we replaced the 2 left lanes, took a 3rd lane as a buffer lane, and pushed all the traffic to the outside. Again, all done in an 8-hour work window. And then this just shows the other traffic setup on the other side. On the other side, we actually replaced a 27-foot wide panel. There's an actual crown between the 2 left lanes, so we actually put 2 12-foot panels in, and on the other side, an actual 27-foot wide panel. You can see where we have the crane set up. In the way it looks right here, something we mentioned maybe in some of the previous operations, that these panels, as you set them, you can walk out on them as you go. So you can get this, as we've heard, a train operation. You've got demolition moving forward, and then you've got installation moving in right behind it. So this is a really good method of travel with your construction. This was actually our work we did on a ramp, and it shows pushing traffic onto the outside left lane. We actually were able to work out an understanding with the DOT that we actually shut this ramp down, detour traffic, and we cut 2 weeks off of the impact on the ramp. So we were actually able to speed up the construction by closing down the ramp, detouring it during the nighttime hours when there's just a little bit of traffic. So execution of work and strategies, and what I like to call strategies is planning. Okay, we've heard a lot about the design of this system and how the system works. Now to go out here and build it, this is probably 60% preparation and planning, if not more. The work you do ahead of time is what makes this operation successful. Okay, we've heard some horror stories about some contractors. We've heard good stories about other contractors. Well, it's going to be a group effort in order to make a project successful. And when I say group effort, that's the owner, the contractor, the precaster, the designer, everyone putting their heads together and working in collaboration together. And that's your planning. And you say an ounce of prevention is worth a pound of pain. I think that's how that goes. And that's what it all is. We thought about our traffic control. We had to make sure we had our appropriate materials. We practiced our MOT setup, our maintenance of traffic. The first night, the only thing that we did as a contractor was we went up, we put up our lane closure, and we took it down. All right, because I have an 8-hour work window, and I can't afford to spend 2 or 3 hours putting up my traffic and then start ripping holes in the pavement. And it was a good thing we did because we were in Fairfax, Virginia, and my crash truck ended up in Arlington, Virginia. So that first night, I set up my traffic, took it down. The next night went perfect. We went out there and went to work. So again, preparation, practice, planning, that's the key to success with these fast-track jobs, these 8-hour windows. Access to the work zone, again, preparation. How are we going to get ourselves out there? We have to set up to use equipment that'll mobilize itself. Okay, we're going out onto a roadway that we're going to reopen to traffic, so we don't want to take track equipment out there. We don't want to have to load it up on a lowboy. We want to make sure that it's on rubber, we can drive it out, and we can get to work. We want to make sure it's staged at a location nearby. Again, everything is time sensitive. So we also want to keep our crew sizes to a minimum to prevent crowding of the work zone. As you noticed, there's a lot of slides up here with a lot of people, as Kirsten said. A lot of those are onlookers. Our crew size was only 12 people, plus 2 operators. And, of course, myself, which I don't count because I didn't do a whole lot of the work. The guys did the work. And that was all we had out there to replace, in 3 months, over 500 panels on this interstate. So, again, 1 crew, keep them to a minimum, keep your equipment to a minimum, and keep it mobile. And then preparation ahead of time. Perform as many operations ahead of time as possible. We went out ahead of time. We did our saw cutting nights before. We drilled for any of the areas where we had to put Sullivan pins in to pull our slabs. Anything you can do ahead of time so that when you get out there to start this work is an advantage to the schedule. Existing conditions. Now this is where it gets a little tricky because we don't know what you're going to get into when you get out there. So this could make or break your production. So you start off small. The condition of the subgrade was good in our case. Had it been poor and we had to undercut, we would have been severely impacted. So what we did the first night, and again, this is newer technology to a lot of contractors, we started out with 4 panels, all right? We figured we could do at least 12, but we're gonna start out with 4. First of all, it's new to us, we're not sure, we wanna be cautious, we've planned, we've prepared, but something can still go wrong, so we went out and we started slow. We also don't know what's going to be underneath those panels. So the first 4 we ripped out. We're checking the subgrade. What are we looking at? What can we expect going forward? If there was a problem, we had materials stocked off site in case we needed to fill in an undercut. We had additional cold patch in case we had to fill in a big hole. So all these things that we had set aside, contingency plans, and even then, something still could go wrong, but you have to minimize that. And again, you can see here, which if you've seen a lot of slides, we removed our existing concrete with a rubber-tired excavator with slab bucket attachment, and I think we've seen a lot of those slides. You'll see another one again here coming up. Preparation of the subgrade to match the existing conditions. Advanced survey of existing roadway to establish grades for the new panel placement. That is critical. Okay, people have said it, measure once, measure twice, cut once, excuse me. Well, survey of the existing roadway is key. And when I say that, I mean actual, survey crews go out there, take exact readings of the roadway, because what you're putting back is not going to match what was on the original as-built plans. Okay, roads settle, roads, deteriorate. You're matching existing concrete to new concrete. You can't just go out there and say, okay, we've got a 2% cross slope and run with it. We actually made that mistake our first night. We had as-built the roads. We had our survey crews there. We went back in, instead of putting in the plan grades provided, we put in the as-built grades, and those panels fit perfectly. So as-builting of the roadway is very critical, especially, and we had already planned on doing this. We used warp slabs out there as well. Having that initial survey is crucial. And then we did have the hand-operated grader. We had precast panels supplied by Fort Miller. That was their system. We actually, utilized our as-builts to set up the precasting of those panels and the installation. But we had to make sure we prepared for this. This is something we actually practiced. Another thing to prepare for, material deliveries. All right, and again, this is something you want to think about as owners and as contractors is precast panels were staged and brought out at night. So we actually staged some panels on site, so we had them there available. We actually had some panels delivered from the precaster. It was a lot of coordination, a lot of advanced planning. Which panels do we want when? How are we going to get them? Talking with the suppliers, making sure that we got the right panels, because a lot of these panels are specific and a lot are repetitive. So it's not always one for one. Oftentimes it is, but it's crucial that you plan this out. And then, of course, we had other miscellaneous material always staged and ready as we needed it. And then the last thing here, you can see weather. If we have a hole in the ground, it starts to rain, we keep going, okay? Once that roadway is closed down, we've got a hole in that ground, if it starts raining, the morning commuters aren't going to go to work later. So we had to be ready to continue on to work and get that hole filled in. Nice thing about the precast panels is you can put them in the hole, they're not gonna melt, they're not gonna, affect your water cement ratio, they're ready to go, they're right there. Again, as a contractor, big fan of being able to know that I'm gonna be able to put that panel that I've got right there in the ground. If I get a rainstorm and I'm trying to put in accelerated concrete and I've got, the deluge coming down on top of it, I'm gonna be ripping that back out again. So, just again, another thing that we had to think about when we were preparing for this work. So again, getting to the execution of the work, I'll point out a couple things that I look at as a contractor. I know you've all seen this picture before, but the one thing I like to point out is it's dark, it's night, there's live traffic next to us, all things that make it a little bit more touchy type of construction work, but very doable. The nice thing about it is you don't have a lot of traffic, and with proper lighting plans, which, as DOTs and as owners, oftentimes is in your specification. It's not impossible to make sure you've illuminated the work zone correctly. Just something to think about, something we did. We submitted plans. Again, another thing that we prepared for. Again, here's a picture that you've all seen. Again, I want to point out the fact, the reflective safety gear, the minimal amount of equipment. This is just my crew. You don't see a whole lot of other guys out there. This is what it takes to build this. We used the same crew in this project to do the demolition as we did to do the grading, as we did to do the installation. So if you look over on the, you look at our skid steer loader, again, rubber tired tracks. That piece of equipment sat off on the side behind guardrail. When we came out to go to work, guy jumped in the seat, drove it out to the work site. He was there within a couple minutes, and we were ready to go as soon as traffic was set out. Again, something to think about. This is a mobile operation. You want to be able to move quickly. Setting the panels, again, a picture you've all seen, but I want to point out right there is where the live travel lane is. So what we have here is 2 lanes we're replacing, a lane to stage our trucks, and then we've got live traffic over there. Our crash truck actually sits just behind here, per the MUTCD. But, it's not necessarily, I want to say it's not the safest in the world because you don't have protective barrier, but what we do in construction is a dangerous business. That's why paying attention to the safety aspects, the features, the safety vests, the traffic control setup, that's all part of our preparing for this work. We took it very seriously, and because of that, we actually had no injuries. We actually had drunk drivers that came into our work zone. Again, we're doing this at night. You got people coming back from the Redskins game. You've got people coming back from the bar. I think 3 drunk drivers were actually taken off in the handcuffs out of our work zone throughout the course of this project. But again, all our traffic control is set up appropriately, our crash truck's in the right location, so where those people actually entered our work zone was way down past where we were actually performing the work or ahead of our safety devices. But it is tough work, but things we all have to think about and consider when we're building this type of work in fast track. This is a picture, and I show this one specifically, I added it last night. That shows the post-tension system, the pre-stress post-tension system. And if you look right here, where it's hard for me to see over there what you guys are looking at. Right there is where they're putting in the temporary post-tensioning. Now, one thing I've heard and that I've seen, this job was over 2 years ago, there's been advancements in this technology. We actually had an issue with grout leaking from those locations when we came back to grout the tendon strands and the duodag rods. And I believe now Caltrans has actually come up with a method of sealing that duct up so that you're not losing the grout out of there. So again, this product is getting better as we go forward, and it's good to hear that coming back as a contractor, because let me tell you, we lost a lot of grout right here out of these joints. Lessons learned for a contractor. This is our temporary post-tensioning that we would do. When you go out there to build this, make sure you leave enough space between the existing concrete and your new concrete to operate your jack. We had a little bit of an issue with that the first night we were out there. Again, since we bit off a smaller chunk, we were able to spend some time, modify our jacking operation, and then the next night create a larger area for those guys to work. I can show you again the picture you've seen before, but what I'd like to point out here is our safety aspect of it. Taglines. These panels, very easy to tag off on either side, keep your guys away from these heavy loads. You're able to set them in place. Then once you get down to it, if you look here, again, these guys' hands are on the top, but what you see in this gentleman's hand is the positioning bar. This gentleman and this gentleman both have them. That way we can set that in there without pinching anyone's fingers. Again, these things are heavy loads. It seems like they're easy to handle when they're elevated, but once they get moving, they will, pinch fingers, break fingers. They'll also crack themselves if they bump into each other. So no matter how careful you handle them, you have to take precautions. I know this system, there's actual shims that go along the back joint so that when you touch this panel to that panel in the back, you don't crack the slab. Again, just another picture of the guys bringing it into position. You've got one guy directing the crane, doing the correct crane signals. Again, preparation, practice. We actually practiced this installation off-site ahead of time. I highly recommend that for any folks trying this as a new operation. Make sure the contractor, meaning us, practices this operation. Again, nothing but preparation, is going to make this go any better. And again, this is just a picture of what goes in. I haven't seen this very often. This piece right here is actually supplied by the system that we're replacing here, which came from the Fort Miller Corporation. This is just a temporary block that went in at the end of the operation for the opening from the new to the existing for the next section of work. So I show that out there just so you know that we did utilize that. And this is a generic photo that I think everyone's put in their presentation up till now, just showing the grouting of the panels, and I won't go into that. We've talked about that enough. Construction's issues and lessons learned. Survey layout is a must for expeditious installation. You've got to have proper as-builting. You can't go out there and have your panels not match the existing roadway. As a contractor, I will tell you, when you've got 8 hours to get these panels in and $100,000 an hour liquidated damages if you don't open to traffic, you do not want to have any deviations or issues where you have to be pulling these panels back out. Spalling at the corners and mid-slab cracks. Again, I mentioned using shims on the vertical faces, so even if you handle these slabs carefully, it's still concrete, subject to spalling, brittle on the surfaces, and even being very careful, if you just touch them, these things they weigh 12 to 16 tons in some instances. So you've got to be very careful and take every precaution you can not to spall it, because as an owner, they don't want spalled concrete, and as a contractor, you don't want to be replacing slabs at your own expense. Make sure you use your crane pads on your outriggers. No sense of damaging the slabs you just put in with your own equipment. And everyone said it already, and I'll say it again as a contractor: grout your panels as soon as possible. This is a train of installation. You do the demolition, you do the grading, you do the installation, and maybe not the first night, but by the second night you can start doing the grouting behind you. So again, everything follows everything else in a linear method. Tying into the existing concrete may not be easy. And I'm going to show some pictures of this here shortly, but suitability of the existing concrete is an issue, and longitudinal tie bar layout could be an issue. And I'm just going to skip ahead to some of the issues regarding this now. This is actually a post-tension slab, and this is going to get me into our precasting. These panels were actually all cast well within the tolerances of typical precast concrete pavement. However, if you notice here, this is wider here, and it gets shorter up in this area. If you have a precast panel that is going to be post-tensioned, okay, and I haven't heard this mentioned yet, and if it's just slightly out of tolerance or skew at the joint, as you post-tension that, the next panel will want to follow that joint. And as you post-tension the next one, they'll want to follow each other. So all of a sudden, a 1/16 of an inch in deviation on a joint after 20 panels has now grown. And that's what we saw here, okay? Now, what ends up happening is this panel slides out this way, puts pressure on this end, and what you could end up doing is actually cracking your keyway, which actually can happen for other reasons as well. But I point that out as an issue. Now, when you have a precaster, and you talk about perhaps pre-qualifying contractors, you want to talk about pre-qualifying precasters as well, because when the owner of the company comes out and sees this happening, what you end up is with this next time. All right, so our precaster cast everything to within, you know, millimeters. I mean, they were phenomenal. They did a great job. Couple things off the bat. They were, you know, still within tolerance, but they got tighter because they didn't want to see a bad product out there. They want to build more of these panels. I talked about the new tying into the existing. This is the existing longitudinal joint. This was all hidden underneath a tape paint. And when we came out there and actually demoed the lane that we were replacing over here, all this fell apart. And we talked about potential cracking in slabs. If you notice where this this transverse joint is here versus where the transverse joints are here, you want to be careful where you place your longitudinal tie bars, because if you place them on either side of this joint, you know, you've got new concrete and old concrete, and one of them is going to give, and then you end up with a slab crack. Now, the nice thing about this, with this system, since it's continuously reinforced, that crack hasn't grown. And then we sealed it with methacrylate, and we were able to move on. Continuously reinforced slabs make it sort of nice that way. There's a difference between plan grades and existing grades. I talked about that. You want to make sure you match your existing grades so you can open up to traffic. Subgrader can make and break your schedule. Trial installations will save you a lot of time and money. Practice, preparation. Nothing else that you can tell a contractor, and a lot of times we don't want to listen because we know it all, is practice, 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 especially in this situation. Staging area is critical for deliveries. Allow time for accurate precasting. This project actually was held up a little bit getting out on the street, so we were actually under a time constraint with the owner and their funding, so we really had to get going with this, and our precasters had to hurry in order to make this happen. If you can allow for advanced precasting, it allows for a better product, allows for a better construction schedule. I highly recommend that. Our overall work window, and I'm running out of time, so I'll just get to I'm almost done. We had an 8-hour work window. We gave ourselves about 45 minutes for traffic on either side, left us about 7 hours. We started off with 4 panels our first night. By the end of the project, we actually peaked at 16 panels, but I left it here at 14 because those 16 two of them were a little smaller. But we were able to put in about 224 feet or 68 meters of lane length, or 248 square meters of pavement with one crew. Okay, I want to point that out. And it was a demonstration project. I personally, having done this now, would love to see a large-scale project where you can get multiple crews out there and then see what your square yard price does once you get a higher volume contract out there. I would think you'd see your costs maybe even become more comparable. That's where I'll leave it. Again, tried to fit about 2 hours of knowledge into 20 minutes, and I hope I didn't go too quick, and I hope I offered some new information.
Is there questions?
On the project, I know there was some diamond grinding done on the completed surface on I-66. Do you know if there was any data from the VDOT as to before and after IRI numbers?
I do know they had before and after IRI numbers, and I can tell you there's a significant difference prior to grinding and then after grinding, obviously smoother after the grinding. I cannot tell you what the numbers were off the top of my head, again, being 2 years ago. But the diamond grinding obviously making a much smoother project. And with this installation, again, we're doing piece by piece. It's not slip form concrete pavement, so you're not running off a string line. You're using precast slabs. I think if you're going to leave this open to, as a riding surface and not overlay it, obviously diamond grinding is very beneficial to the project. It gives, and it gave us great ride. And I've ridden over those panels over the past couple of years, and they still ride as smooth as the day that, safety grinding and grooving ground them.
Other question?
Thank you.
All right, thanks a lot. It's for me, it's interesting to hear about a contractor that is so enthusiastic about precast slabs. So I'm very happy to hear that. So our last speaker, Mr. Nen Nguyen Din. Mr. Din has a master's in science in transportation systems from Munich, Germany in 2011. His research interests are road, airfield pavements, and railway superstructure. Currently, he is pursuing a PhD in the topic Precast Concrete Pavement System for Electrified Roadway, Singapore case study. He will present us the topic using precast panels for dynamic wireless charging of vehicles in Singapore. Mr. Din, the floor is yours.
Thank you, Dennis, for the introduction. I'm very glad to be here. Oh, it's really long flight from Singapore, so I still feel like midnight for me now. Okay, everyone was talking about good performance of precast concrete pavement, and now I will bring in and introduce you the whole new application of precast concrete pavement for electrified railway. My topic is a bit different, but no worries, it's just the name. So actually, I'm from the chair and Institute of Road, Railway and Airfield Construction from TU Munich. I'm being sent to Singapore for a project called TUM Create. So I'm working under the supervision of the Professor Stefan Florenstein and Dr. Bernhard Lechner. Okay, so let's start. The scarce supply of fossil fuel and the need of greenhouse gases emission reduction have driven the development of electrical vehicle worldwide. But as you might see, the adoption of electrical vehicle is not dominant because of its battery-related problems. So as I list there, firstly, the battery is very expensive. So 1 kilowatt hour battery may cost around $700 or even much more. It means one battery like a Nissan Leaf, a very popular electric car of 24 kilowatt hour may cost around 17 to 18,000 $. So it's more than half of the vehicle price itself. The second thing is the battery is very heavy, and it is the heaviest part of any electric vehicle. So, and the heavier the battery is, the more energy needed to carry it around. Rent limitation is the main issue that stop people buying electric vehicle, and the charging time. The most popular charging type is the plug-in type, and the fastest charger now can charge electric vehicle from 0 to 80% in around 20 minutes. So this is quite fine with many users, but for some users like fleet operation like taxi or the bus, this is not really convenient because you cannot tell the passenger on board that, okay, just wait 20 minutes to get the vehicle to be charged. Okay, so how to overcome this problem? By the way, just introduced, this is the electric car developed by our university, TU Munich. This is quite famous now. Okay, so how to overcome this? The answer is electrified railway. So electrified railway is the railway that is equipped with electrical device inside that allowed energy transfer wirelessly to the vehicle using inductive power transfer. So as you might see over the picture, if the vehicle traveling on of the electrified railway, the section where the vehicle is on top are triggered on and allowed to create the magnetic field. And this, the pickup device mounted under the vehicle will transfer this magnetic field to power to charge the electric vehicle or to propel the engine. So let's imagine you can charge the vehicle even when driving. So if the electrified railway is installed at the right place in the city, so there will be no more range limitation because you can charge every time you need. And by that, the battery capacity can also reduce a lot. So there's no more heavy, expensive battery. So this makes the electric vehicle much more attractive. So for this, I believe that electrified railway could overcome all of the battery-related problems of electrical vehicle. Okay, and when I present this to some of my colleagues back in Singapore, and they even asked me, okay, is that science fiction? Will it be true or not? So I explained by this, actually, this idea is not new. At the end of 19th century, these two authors, Maurice Horton and Maurice Leblanc, they patented their invention called transformer system for electrified railway. Actually, this railway is not railway, but this is just 10 years after the first electric tram introduced in Germany. So they recognize that the problem of movable contact between the catenary and the pantograph will cause a lot of problems. So they invent this using transformer to transfer the energy wirelessly to the tram. It's no more movable contact. But this idea, I think there's no application, but they have a very good, very good invention for future development. So how about the roadway? During the oil crisis in United States during the 1970s, so this idea was renewed. And California Partnership for Advanced Transit and Highway, UC Berkeley, they introduced a project called Roadway Power Electric Vehicle. So in this project, they demonstrate test session within the campus. This test session was around 200 meters with 2 power sections. So these 2 sections width of that was 60 meters long, and a 35 passenger electric bus was used for this testing purpose. And the vehicle by then can run around 300 kilometers compared with just only 25 kilometers of battery power only. So it was amazing result. Even the efficiency of energy transfer was quite low at 60%, but this was recorded at the first successful test drive in electrified railway. So what happens now? Some years ago, KAIS, this is Korea Advanced Institute of Science and Technology, they introduced the online electric vehicle called OLIF. So they successfully demonstrate their technology in some of the test track, as you might see, in their campus and in the park. So their system performed really well during all of this demonstration. The efficiency now can be high up to 80%, and they can overcome the air gap between the surface of the pavement to the pickup device under the vehicle around 20 centimeters. And as you might see on the picture, they can reduce the battery to 2/5. So it was amazing result. Yeah, but this is not the only company now available. Another company is Bombardier. So they introduced another solution, is Pavement. So they use the same technology, but just different name. So they also make a successful test, firstly for the tram application in Augsburg, Germany in 2010. And at the end of the year, they make another successful track in Belgium. I think some of the college in Belgium yesterday was introduced some of the picture of that. Yeah, and the most interesting thing is that now the company, they already signed the first commercial bus project in Braunschweig, Germany. So this was amazing result. And this was 12 kilometers bird route, and with 2 electric bird running on that using this technology. So hopefully we can see that soon under operation. So for this, I believe that this electrified railway idea is ready for the market. Yeah, but consider, as we are a civil engineer, we consider the pavement for that. So during the test section, the company like Kaisolip or Prime Move, they also introduced their pavement for this purpose. As you might see from the picture from the lab, so with a lot of sensitive electric device in this way, asphalt pavement might be not the right choice. And how about concrete pavement? If you see these 2 companies, they use cast-in-place concrete. The Prime Move, they use the precast one, but later on they still use cast-in-place for finishing. So with this equipment, as you see from the lab picture, if with this configuration, the heavy machine is not the right choice. Like a slip-form paver for fast paving is not no more the right choice, because it might break on the equipment inside, or this might make displays the location of on the equipment. So and the more restricting for me is that as you might know, the pavement with a lot of equipment inside like this might be really expensive, or it might be expensive. So normally it had to be installed at the most traffic, the heaviest traffic section to use it more efficiently to compensate for very high initial costs. And as you might know, with this place, the cost for delay, the cost for land closure will be really, really high. So I think for this application, no pavement is better than precast concrete pavement. Okay, so back to Singapore. So what does this, with the whole concept, mean to Singapore? So as you might see from the statistic, the taxi, you rarely see the taxi stand still in Singapore. So they run in 2 shifts, and 1 shift average daily mileage is around 260 kilometers. It means 520 kilometers per day. With public bus, that number is 250 kilometers. So it's pretty high. And more interestingly, Singapore is really humid and very hot on year round. So the air conditioning working on the time. So as you might know, with the electric vehicle, if Singapore would like to turn on of this vehicle into the electric vehicle, it might be a problem, because with air conditioning on, the consumption of air conditioning might be 30% of the energy used. This is really a lot. So for this application, I think the idea of electrified railway really makes sense. Okay, so see this potential. We are at Tum Create, and I'm in the cluster D, infrastructure and transportation. We form up a team working on this. So there will be a topic working on the electrical grid to see, okay, that if we implement this idea, if the electrical grid can handle this or not. The second topic is really interesting, to simulate the traffic and to predict where should be the location of the charging land of the electrified railway, and how many % should it cover and my topic is the precast concrete pavement system for electrified railway. So hopefully the vision for Singapore in the future, we have a map somehow like this. The red dot is the charging land. The intention of this map to say that, okay, we don't destroy the whole city for electrified railway. It's just only some spot. Of course, in reality, it will be more. but namely some of the interesting place for this charging lane should be, for example, taxi stand, very high traffic section, and as you might see, the bus stop is really very suitable location, or in front of the red line. And when I come to Singapore, I see this is really interesting, because in Singapore they turn on of the bus stop and the heavy high traffic volume junction into concrete. And let's see if we can implement the precast concrete into this place, and then we can also overcome the problem now happen in Singapore, because in Singapore the concrete pavement is used limited only at this location, because the main problem is they have really heavy traffic, and the time for repair for this is really horrible, really costs a lot of money. So I hope that this idea, when it comes to Singapore, it can have additional benefits. So in conclusion, I can say Electrified Railway, they make the electromobility much more attractive. And the precast pavement technology, they have to implement this idea into the road network, the road system. So it means this technology will push the whole concept. And this whole concept is very interesting for Singapore. And the precast concrete pavement also creates additional benefit for Singapore. Okay, thank you for your attention.
Hello. I just have a comment in terms of, because you were looking into what roads, where in particular might users benefit the most of having this technology in it. I don't know, obviously you have high traffic volume issues, but I don't know, do you guys have any high occupancy vehicle lanes in Singapore where you have two or more drivers, like in Toronto and Ottawa as well, you have that?
Mm-hmm. Yeah, currently Singapore, they don't have the HOV.
Okay, and maybe that could be a benefit, that the HOV, if you were to develop some lanes like that, where it also has the use of, okay, to promote electric vehicle use, that you have some of these roads that have this technology set up to promote either electric vehicles and also high vehicle occupancy vehicle lanes.
Okay.
So,
Yeah.
thank you.
Thank you. Yes.
Yeah, I was just curious. So many users will be like charging their car on that system. How do you know like who consumes what, and is there a technology for that, or someone has to pay for it, right?
Yes. Actually, the idea, I'm not working with the electrical stuff for sure, because I'm a civil engineer. But the idea for this is to have some, anyway, they have to interface the connection between the vehicle and the pavement. I mean, it's transferred wirelessly, but they should have sent some signal. Otherwise, as you might see from the first picture, it's just only the section when the vehicle is on top is turning on. So it means there will be some connection. It's maybe a wirelessly connection or some kinds of interface, some kind of communication. And this communication, also the collecting of the data from vehicle. So you will know how long the vehicle will stay there, and how many energy it withdraw from the system. And this also creating another benefit is for the traffic information for ITS system. So you collect all the data, you know where the vehicle is. Of course, this is no name, but you know where the vehicle is, so you can also somehow navigate the vehicle to the right sections to prevent the traffic congestions.
Other questions?
Yes.
This might be too technical, but what kind of conductors are you actually envisioning will be embedded in the precast?
Actually, this idea is the inductive power transfer in resonance. So they use inductive charging, as you might see a lot on the, for example, the toothbrush or some of the mobile charging over the wirelessly charging. So they use the same idea, but they use the resonant one to overcome the distance because the car cannot touch the pavement. So they would have some kinds of distance, the air gaps.
How deep do you embed the hardware in the precast?
The hardware is might be the tip of the hardware might be around 5 centimeters.
Other questions? No? All right, thank you.
Okay, thank you very much.
Thank you, Mr. Din, for a very futuristic presentation. This is a great use of a precast slab, and I think it will be interesting to have an update maybe in the next conference in 4 years. So as you know, this ends up the presentation part of the workshop. All the speakers are in the room, so if there's questions, just feel free to ask your questions, and after that maybe we'll wrap up the workshop and leave you free for the afternoon. So is there other questions? Sure, nothing? All right. Okay, then I would like to thank all the speakers for their excellent presentations. I think that with the technical session on precast, pre-stressed concrete pavement held yesterday morning and this workshop, we will leave this conference with the state-of-the-art of the practice of precast slabs. Of course, you were a great audience. Please note that the presentation should be in the final CD of the conference if the speakers agree, of course, to put their presentation in the CD. The CD will be sent by mail to you. I would like to give a special thank to Mr. Peter Smith, who from Fort Miller, who put up together this workshop. And finally, thank the National Precast Concrete Association for the sponsorship of this workshop. So you can go to their website, precast.org/pavements, to have information. So you have all sheets on your desks, so you can keep them and go and look for information. So as you know, this afternoon is free. And I think the lunch, there's no lunch also served. So up to now, you're free for up to tomorrow morning. So thanks a lot, and have a nice afternoon. Thank you.